Assalamualaikum everyone and welcome to Mathematics with Shahab Yaqub. So now let's look at this colorful word that is integration. Yes, integration of P3 has so much variety in it that any normal person can get confused. For example, if you look at these circles, you will see some integrals which are very similar. Now, how to decide which is the right technique of integration? The method of integration is called technique. So, which is the right technique? We have to decide. So, let's get started. First of all, in these boxes, let me write the common techniques that could come. So, first of all, I'm starting with this thing, which is known as chain rule of integration. So what is the chain rule of integration? That is integral ax plus b raised to power of n, and we write a dx over here. That is increase the power by 1, divide by the new power, also divide by the derivative of the bracket or coefficient of x, and don't forget to write a constant of integration. Now, first of all, is this rule valid every time? The answer is no. This rule is valid and it has some limitations. What are the limitations? The first one, the expression ax plus b is a linear expression. It's only valid for a linear expression. The second limitation, the power of n could be anything except -1. What's the issue with -1? If I take -1 over here, -1 plus 1 becomes a 0. Any fraction divided by 0 will become undefined. So therefore, this is not possible. So this is the chain rule of integration. That is the first technique that I've written over here. Let me move to the second and the third technique. The second technique, and even before that, let me just make a copy of this and let me paste it on the side. So the second technique is this, that is, we will write 1 over ax plus b, and it has a power of 1 in the denominator. That means it has a power of -1. When we integrate this thing, we get 1 over a ln ax plus b plus a constant of integration c. It's preferable that we put a modulus sign over here. Why? Because ln only exists for positive values. That means when the chain rule fails, this will come into action and we will get this thing. That means if we differentiate this, we will recover back this. That is just giving you some extra touch. Extra additional support knowledge touch. That means you should be well aware that differentiation and integration are reversible process. Another application that is more generalized, that is, if we are talking about something like this, if the numerator is the derivative of the denominator, then the integral is ln of denominator plus a constant of integration c. So basically, this is the real rule, and this is an application which can be studied in comparison to the chain rule. So now let's recap. You need a lot of patience, a lot of stamina, a lot of endurance in order to solve questions related with integration. If you miss out on these, you will never be able to understand this. That is why let's go easy on it. Chain rule of integration, this is the chain rule, that is the limitation. This happens when the chain rule fails. You have a linear over here. It has a power of 1 in the denominator, which means this is ax plus b raised to power of -1. And that is the integral. This is the generalized form. That is, if the numerator is derivative means differentiative of denominator, then the integral of this fraction is ln of denominator. Another technique which is even similar, that is of the format 1 over x square plus a square dx. Something like this. This is 1 over a tangent inverse x over a plus a constant of integration c. Again, if we differentiate this, we will get back this. This is something that was included from the May-June 2020 syllabus. So now, this is not that old, it's relatively new as compared to the other things that we have studied. Now, keeping this in mind, let's go to each single question. So if I start with this question, that is this thing. First of all, highlight it. This is an application of chain rule. Why? Because it is linear and the power is anything but -1. So let me write it out. This is x plus 1 raised to power of -2 dx. That is x plus 1 raised to power of -2 plus 1 divided by -2 plus 1. Even though the coefficient of x or derivative of bracket, which is the same thing, because if it's a linear expression, the coefficient of x is the same thing as derivative of the bracket. So that will be this thing, a. So over here, even though it's very obvious, it's 1, make a habit of writing it, plus a constant of integration c. So this is x plus 1 raised to power of -1 divided by -1 plus c, and this can be written as -1 over x plus 1 plus c. That is how this integration is done. Believe me, integration is not difficult. It's just the spectrum is too wide. So you have to use a lot of memory, a lot of recalling, so that you need to know exactly what needs to be applied in which scenario. So this is worked example 1. Let me write over here. So this is worked example 1 and this thing is done. Now over here, let me label it worked example 2. What exactly is this? This is also an application of chain rule, because I'll write this thing as 1 over x plus 1 and a power of half is in the denominator. Let's take it up. So therefore this is x plus 1 and this is -half dx. A word of caution, go step by step. Don't haste into doing things all at once. What I simply did over here is to take this up. I have not yet integrated it. Keep that in mind. Now let's do the integration. So this is x plus 1. It's a linear expression. The power increases by 1. Divide by the new power. Divide by the coefficient of x or derivative of bracket, which is 1. Simplify it further. So this is x plus 1 raised to power of half. This is 1 over here. -half plus 1 is half. Division by half is multiplication by 2. So this is 2 square root x plus 1 plus a constant of integration c. What I have done is that I have replaced this half with this square root sign. I hope it's all got all clear. So again, this is an application of chain rule of integration. Now the third one, what is this? This one, by now you have realized that worked example 3, it is about natural log integration that gives you natural log. So 1 over x plus 1 dx, first of all, right, chain rule is not applicable. Why? Because the power is 1 in the denominator, which means it's actually -1. So now the coefficient of x over here is 1. So I'll write 1 over 1 ln of the denominator, which is x plus 1 plus a constant of integration c. Advisable, to write the proper mathematical etiquette is that you should write a modulus sign whenever ln appears. So now that integration is done. Very short, very simple. What about this example? This is worked example 4, and this time this is x over x square plus 1. So now let me just flip this back, and this is x over x square plus 1 dx. Now focus on this. Is the derivative of x square plus 1 2x? Yes, it is. So what is missing? A 2 is missing. Balance it out when you multiply and divide by a constant. That is called balancing out. That is multiplication by 1. Now this fulfills the criteria. Let me write over here. That is this thing. If the numerator is the derivative of the denominator, then the integral is ln of denominator plus a constant of integration c. So this half on the outside remains as it is. And what happens on the inside? That is ln x square plus 1 plus a constant of integration c. So now just over here, just a double check to give you a clear-cut idea that if I differentiate this derivative of bracket half ln x square plus 1 plus c, you can just ignore because the derivative of a constant is 0. So half remains as it is. X square plus 1 goes down. Derivative of x square plus 1 is 2x, that goes up. And this 2 and this 2 cancels out, and you are left with x over x square plus 1. And that is double checking it even before the examiner does it. Also over here, let me write the rule so that you remember exactly what is happening. This is 1 over ax plus b dx, which is 1 over a ln ax plus b plus a constant of integration c. And the first two were application of chain rule, which is right over here. So chain rule is done, this is done, this is done. I think it's about time for this one. Let's have a look. So now this is worked example 5. So now worked example 5, that is application of this rule. Let me write it over here. Integral of 1 over x square plus a square dx. So this x square is there, and instead of 1, technically it's 1 square. So that is 1 over a, and this is tangent inverse. I was about to write ln because I'm so obsessed with ln. So that is x over a plus c. So this is integral 1 over x square plus 1 square dx. So therefore just realize the fact that this is a square. Therefore a is 1. So this is very simple. 1 over 1 tangent inverse x over 1 plus c, and that is the answer for this part. And let me label it over here. This is worked example 5. Very simple. Last one, the surprise element. What is this? Now first of all, you need to simplify it first. That means I should do long division, algebraic division. So x goes inside, x plus 1 goes outside. The coefficients are the same. So x over x, this is 1. Multiply with both of them. So that is x plus 1. And then change the sign and add. That is another way of subtraction. So I'm left with negative 1. So first of all, this 1 over here, that is the quotient, that is 1. This negative 1 over here, that is the remainder. And this thing over here, x plus 1, that is the divisor or the divisor. So I can write this thing as quotient plus remainder over divisor. That is 1 minus 1 over x plus 1. If I'm not mistaken, yes it is. So now integrating this thing, this is worked example 6. That is the same thing as integral of this. So integral dx, 1 basic integration, that becomes x minus remains as it is. This is another application of ln. Let me write 1 over here. So therefore this is 1 over this particular one, which is the coefficient of x. And then what do we have? We have ln, and this is modulus x plus 1 plus a constant of integration c. So that's how this is done. So what have we learned so far? We have learned that about chain rule, and we have learned about natural log integration that gives natural log, and we have learned about integration that gives tangent inverse. And yes, there was a case in which we had to simplify first and then integrate. So basically, your vision should be very clear. Your observation is what will decide which is the right technique for integration, and that's all about in this particular video. Stay tuned for more mathematical content.